Hello, everybody. It's April week 4. We got the community team here with another demo system by update by operations.
Thanks, Bender. So I'm sharing my screen now, and I'm going to paste a URL in the chat here of this Google Meet we've got so that other people can hit this and try it out if they want. But thanks to a lot of hard work mostly from Chip, but a little bit from myself and a few other people, we have essentially a basically almost ready to ship prototype of a new demo system. This new demo system has two different experiences built in. It has a code studio, which is very similar to the demo system that we have all seen and probably touched at one point or another. And then it also has a Jupyter demo. I'm going to focus on running from Jupyter for the most part for this demonstration, since we've all seen a code studio before. But just know it's all there, and it has been tested pretty rigorously, and it should work pretty seamlessly. So also as a part of this presentation, we're hoping to get a little bit of stress testing done just to see what happens when, whatever, 10 plus people hit the demo at the same time and request a worker. So anyway, if I go here to the, you can actually go to both, but I'll start with the Code Studio. It uses CAPTCHA and it looks nice. And then as soon as it's ready to go and it verifies that you're a human, we can head on over to the demo system itself. And so might be a little bit slow because I'm sharing my screen a little slower than usual, but it's got all of the notebooks built in that we see in the current demo system that we have live on the Deephaven homepage. You've got all these nice things, and you can create data, and it's got all this stuff. There's even a couple of extra notebooks thrown in there. For instance, we have one that showcases pulling from Postgres. Sorry, my dogs. Someone came in the door, so obviously they have to bark. So if I go back to the demo system itself, it will remember me, and I can go to the Jupyter Lab demo instance, and once again, it's going to verify I'm a human. Actually, this time it's creating a new worker. Took a second. Sweet. So anyway, this is the Jupyter demo experience right now. Like I said, it's got one demo notebook, but Jupyter looks really nice. It's got a mix of markdown cells with some flavor text, as well as a few code cells. So for instance, this one starts a Deephaven server on port 8080 with 10 gigs of memory. And then from there, look, the server started, so that's nice. Import some Deephaven packages. We're going to consume a Kafka stream and display not only the table ticking in real time, but also a plot that starts to look a lot nicer once you get more data because its price is jumping around. Up next, we perform some aggregations and some row counts, particularly, so this Kafka stream has information about crypto trades. So we're counting the trades, total trades by instrument as they come in. And in the second table, we're actually just performing some aggregations on the data, on the clean data. In the next code block, we do a little bit of filtering, and we showcase some relational joins as well as time series joins in real time, which is one of Deephaven's many superpowers, as I'm sure everyone on this call knows. Do not want to learn about Jupyter News, thank you though. And so here we see the join table, and then I've got an update by code block in here, because update by is awesome, as everyone will probably see shortly when Larry starts to talk about it. And then lastly, I've got a cool plot showing how update by is working in real time by calculating the maximum, minimum, and average price relative to the current price over a moving window of, I think it's currently set to 20 rows. So yeah, that's the new demo experience. So hopefully we can get people to use it and let us know if it's cool or if it stinks.
Very cool. All right. Next, we have Larry. He's going to talk to us about the update.
Okay. So joining the update by family, we've got 6 more operators. We've added some kind of simple ones with a delta operator, which is just shows a difference between the current row and the previous row, but can be useful in certain scenarios. And then getting to the more complicated, we have now an EMS operation, which is an exponential moving sum, and then an exponential moving minimum, and exponential moving maximum. Each of these operations have a kind of a niche case, but we found them to be useful even in our own internal tools. And then joining the windowing family, we have rolling count, which is a really simple operation that'll just count the number of non-null values in a window. We have rolling average was already introduced, but a companion to that is now rolling standard deviation. And those obviously, you can see how they would parallel each other. And then we have a rolling weighted average operation. So I'm going to take a lot of time just demonstrating these. I'm just going to go ahead and kick this off. Let's bring in here a database. This has 2 million rows. So again, just to prove we're not cheating. And this will be effectively, we'll compute all of these operations over a 50-row either exponential moving window or a true rolling window. So here's the differences. We can now see delta is producing a delta price, and then our moving sum of prices are minimum and maximum, and then the rolling count. So this will quickly get up to 50 and just maintain there. Our rolling average, rolling standard deviation, and our rolling weighted average are all represented here. And then this is what we call our kind of our zero key case, where we're not doing anything particularly interesting with the region and item data, but of course we can bucket these in any way we like. So I just have, for demonstration, I'm just going to rerun these, but we're going to bucket everything by region. And what this will produce is it's the same table with all the same data, but now these additional columns. Each of these data values are unique to the region that it belongs to. So we can see like these 2 European rows are the first 2 European rows, and each rolling count is separated, is computed separately for each region, or each rolling average, standard deviation, and weighted average are all computed separately. And nothing is complete without a ticking demonstration. So let's just bring up a real-time data table. Here's our data coming in at basically run row per second, and here are the same 2 operations, but now executing over the ticking data. And this is a zero key case where everything is just computed. So we'll see this rolling count increment every second till it gets to 50. And then our bucketed version, this will be bucketed by region. And this is on real-time data. And we'll see each of these aggregations and computations are being summarized and computed over just the region specified. And that's really it. We're coming near the end of our list of planned operations for update by. We're going to introduce one more for the next release, and then the update by will be at least feature complete. And that's it. Thanks.
Next up, we've got Corey. Next version.
Yeah, let me share my screen here. So this is just, the point of this demo is really just to sort of show a checkpoint of what I've been working on. The idea here was the Python client to access ticking data from Deephaven. And in the previous demo, we were relying a lot on the C++ library, and it was kind of considered to be a better user experience if we could do as much as possible in Python and just have the kind of high performance sort of decoding and index manipulation code and so on be done in C++, but to the extent possible, everything else in Python. And are you seeing my screen okay?
Yep.
Okay, good. And so I've got kind of my standard query up here running in Deephaven. This is this thing where I've got a table with 1 million rows, and it's ticking every microsecond. So the whole table's changing every second, and I'm just calculating kind of a random value in this in64 value column. And because of a slight bug right now, I actually want to just isolate that to the in64 column like this. So now I've got a million rows that's just the in64 column. And if we go over, and then I will do another Deephaven query to sort of calculate the sum. So the sum of the million rows is about 500 million, because each number is a random number between 0 and 1,000, between 0 and 999, and their sum is, on average about 500 million. All right. So to what I do in my previous demo is first I'll run it. I just kind of do had some debug messages there in this regard, but what I'm doing is I'm subscribing to that table, I'm getting all the data over. It's like zooming over to the Python side, and then I'm calculating the sum of that column. And you should hopefully be able to see that the number I'm calculating, over here, 499, blah, 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 something ending in 598. We should have seen that over here too somewhere. Yeah, there it is. So it works great. And so, and just to show you, just to give you a feel of what the code looks like, this is my laboratory, so everything's kind of in one file, both the Deephaven code and the user code, but it's all pretty simple. Like these are our standard library calls to connect to this the Deephaven database. Here we're using the arrow flight calls in here somewhere to start what is a so-called arrow flight do exchange process. A couple other details. I'm formatting a subscription request, and then this is my little loop where I get the next chunk from arrow, and I basically kind of feed that. For each chunk that I get, I kind of feed it to the library, and the library sort of once it's gathered enough data, feeds me back a little package of an assembled next update message from Deephaven. And that's why it's right now it's kind of a doubly nested loop. It doesn't need to be that way. I got to fix that. But basically, get chunks from arrow, feed them to the library, and then if it's sort of a two-way generator style, I feed stuff to the library, and occasionally it gives me stuff back, which I then process in my own Python code. And if you're wondering what untick is, it's basically the code that I showed before. It's just my kind of silly little Python class whose job is to pull out data from the update, process the adds, removes, and modifies, and calculate the running sum. So that was kind of a whirlwind tour, but a lot of this is similar to what I showed before, and that's it.
That's all we've got for this week. And next week.